The question of whether to strive for a low-impedance grounding electrode system, or GES, is a complex one, debated among electrical engineers. Proponents argue for its benefits, particularly concerning sensitive electronic equipment, while others maintain that the GES has minimal impact on electronic system performance. Let's examine the arguments on both sides. Firstly, regarding the protection of sensitive electronic equipment, a low-impedance GES is believed to protect sensitive electronics from voltage spikes and transients. The premise here is that by providing a low-resistance path to ground, the GES can quickly dissipate these surges, reducing the risk of damage. Secondly, concerning improved fault clearance, a low-impedance GES improves fault clearance by reducing the time it takes for a protective device, such as a circuit breaker, to operate. This faster response time can prevent extensive damage to electrical equipment and limit the risk of fire. Thirdly, with reduced step and touch potentials, a low-impedance GES reduces step and touch potentials, which are hazardous voltages that can occur in the vicinity of a faulted conductor, which improves safety for personnel working in electrical areas. Now, let's look at the counter-arguments. Some engineers argue that the GES has a minimal impact on the performance of electronic systems because electronic systems are typically grounded locally. They say the GES only provides a backup path to ground in the event of a fault. The IEEE 1100-1992 standard, titled IEEE Recommended Practice for Powering and Grounding Electronic Equipment, does not specify a particular impedance for the GES. It does recommend that the GES be designed to provide a low impedance path to ground for fault currents and lightning transients. In conclusion, the need for a low impedance GES depends on specific requirements and circumstances. For facilities with sensitive electronic equipment or critical applications, a low impedance GES may be justified to provide additional protection and reduce risks. However, for less critical applications, a higher impedance GES may be sufficient. The final decision should be made on a case-by-case basis, considering factors such as the type of equipment, the operating environment, and the level of safety desired.